Hey guys, welcome back. We're continuing to look at the analysis of variance or ANOVA test. In this video, we are going to do a complete example. So we already read the example in the first video, but we basically got 23 first-year male students at a state university, and we're interested in looking at whether the university lowers their standards for athletes. So I have 8 students who got baseball scholarships, 7 students who got football scholarships, and 8 students who are non-athletes. So we want to look at the comparison of their composite ACT scores to see if there's really a difference. So for the analysis of variance test, our null hypothesis is that all of the means are equal, and our alternative is that at least one mean is different. So my null hypothesis here is that the mean of baseball is equal to the mean of non-athletes is equal to the mean of football players. So all 3 groups have the same mean. My alternative hypothesis is going to be that at least one mean is different. I don't know which mean is different, but at least one of them is going to be different. At the conclusion of this test, if I reject my null hypothesis, I still won't know what is different, but it will give me an idea that I should do some further explanation or further exploration. Okay, so I now have my null and alternative hypotheses, and I have my data. So I want to put my data into my calculator. So I have the data, baseball, non-athlete, and football put into list 1, list 2, and list 3. So one idea that, one thing that people often think of is, I really like the 2-sample t-test. It's so easy for me to do. So can't I just set up a series of 2-sample t-tests between these, right? So I've got one pair, another pair, and a third pair. But what ends up happening is I'm like over checking things, and I'm more likely to reject when I check all 3 things than I really should be. So I need to look at all 3 together. I'm not looking at, are these different? Are these different? I am looking at all 3 of these. Does it seem reasonable that they're from the same? So when we do a follow-up test at the conclusion, we're not going to do a standard 2-sample t-test, but we'll get into that later. Okay, so I'm looking at my data. I have it in my calculator. The first thing I want to do is I want to run through my assumptions. So the first thing I need to do is, so checking my assumptions, independence. I am going to say that, yeah, these groups are reasonably independent of each other. It's not random, but I am told this is a representative group. So that's good. Equal variance or similar spread. Okay, so to do this, I need to look at my side-by-side box plots. So if I go into my stat plots, I am going to turn all 3 plots on, and I am going to choose box plots. So I'm going to make this list 1. Let's turn on plot 2 to a box plot with list 2. And then let's turn on list 3, also with a box plot for list 3. Let's make sure there's nothing in my Y. So then I'm going to hit zoom 9, and I can see my graph there. So I went ahead and sketched this out earlier. So I've got my composite ACT score and my box plots. So looking at my box plots, this seems reasonable. Now, looking at these and looking over here, you can see that the IQRs are not the same for each. Even though we have small samples, the analysis of variance is going to tend to fail on the conservative side. So it is going to fail to reject more often than it rejects. So it's a conservative test. We really need these to be extremely different in order to not meet this criteria. It's going to be okay if these aren't perfect. And then we're going to want to look at the nearly normal, which is going to require us to look at our histogram. So I'm going to switch each of these over to histograms. Oops. And now looking at these histograms, there's not terrible skew. So we're going to say that these are okay. All right. So we are going to perform an analysis of variance. So now that we have checked our assumptions, we are going to move on to actually performing the test. One thing that I like to do before I jump in and do the test is I like to go through and get my summary statistics for each of my data sets. So that means I will go through stat, calc, 1var stat for each of my different data sets. All right, so for baseball, we have 8, 23.4, and 2.1. Instead of going through this, I already have the values from before, so I am just going to write them down. So for non-athletes, I have a sample size of 8. I have a sample mean of 26.1 and a standard deviation of 2.9. For football, I have a sample size of 7, a standard deviation of 21.9, and a mean of 21.9 and a standard deviation of 3.3. So I'm really going to be looking at how do these vary compared with how these vary. So to do this, I am going to go to my calculator. I'm going to go to Stat, Test, and I'm going to scroll to the very bottom is Analysis of Variance. So this is on my calculator, Stat, Test, ANOVA. And then I'm going to hit ANOVA, and it's just going to come up with a command like that. So I'm going to type in list 1, comma, list 2, comma, list 3. So list 1, comma, list 2, comma, list 3. And then I'm going to hit enter. And it comes up with all kinds of information for me. So it tells me my F value. This is my F test value. I have an F test value of 4.56. I have a P value of 0.023. And then it goes into factor and treatment. So factor and error. So factor is the same thing as treatment, or this is going to be looking at the mean square treatment. So this is the variance between the different means. So I have degrees of freedom here. This is giving me my degrees of freedom for the numerator, which is 2, right? Because that is 3 minus 1. 1, 2, 3 is my K value, which is the number of groups I have. The sum of squares is the numerator of the sum of squares is this part, and the degrees of freedom is the denominator. So I'm only going to write down the mean square treatment, is 35.5. Scrolling down, I get to the error, which is the variance within. So again, I'm going to record the degrees of freedom of the denominator, which is n minus k. So they tell me that's 20. So for me, the n is my total sample size. There were 23 males in this program. Minus 3 categories is 20. So that works out. And then my mean square error is 7.8. So what I can see here is if I draw my F distribution, so this is my F distribution, it has degrees of freedom 2 and 20. My test statistic is 4.56, and this is a p-value of 0.023. So that is my p-value. So my conclusion becomes, with a p-value this small, we reject the null hypothesis. There is evidence that average composite ACT score for the 3 groups are not the same. So there we go. Even though we have small sample sizes, the analysis of variance test allows us to take 3 sets of data and look at them and see that they do not appear to come from the same population. We don't know which seems to be different or if they all seem to be different. That's going to require a follow-up. In our next set of videos, we'll be talking about the Bonferroni test, which is a follow-up to the analysis of variance. Thanks for watching.